So, ladies and gentlemen, we're going to go over the first part of the review for acids and bases in equilibrium. This is just the acids and bases. So, question number 1, calculate the hydrogen ion concentration for an aqueous solution in which the hydroxide is 10 to the minus 11. So, we learned before that the hydrogen ion concentration plus the hydroxide ion concentration needs to equal 1 times 10 to the minus 14. So in this problem here, we've got POH is 10 to the minus 11. Now that's just, it really would be 1 times 10 to the minus 11, but we get lazy when it's just a 1 and don't bother to put it in. So if this is 10 to the minus 11, what would the hydrogen ion concentration have to be? Have to be 1 times 10 to the minus 3. Because when you add up all of these exponents, that will equal 10 to the minus 14. Now, we haven't answered the question yet, but that was from the first week working on this, and you've got to know that concept. So let's go on now. What does the question say? So what do we need? Calculate the hydrogen ion concentration. Okay, we did. Hydrogen ion concentration, we just said, was 1 times 10 to the minus 3. And again, when we have the symbols here for concentration, that means it's moles per liter. It's easy to kind of forget that, but that's what that's meaning. Is this solution going to be acidic, basic, or neutral? Well, we got to figure out the pH first. So when you have 10 to the minus 3, 10 to the minus 3, now I can enter that as 1 engineering mode, 3, change the sign. Then you need to take the log of it. On my calculator, it's right here, hit log. Then you got to change the sign, because in the equation for pH, you take the log of the hydrogen ion concentration and then change the sign. So that would be a pH of 3, which most of you know that 10 to the minus 3 is just going to translate right into a pH of 3. Is pH of 3 acidic, basic, or neutral? It's going to be acidic, and I believe we've answered all the questions on number 1. We go on to the next one? Or to the next 2? Okay. Number 2, the hydrogen ion concentration is 1 times 10 to the minus 7 molarity, okay, moles per liter. What is the pH of the solution? Well, we need to first know, this is hydroxide. Now you've got to pay attention. When we give you these on the test, are we giving you a hydroxide ion concentration or the hydrogen ion? So this is hydroxide. And we just said over here that the hydrogen ion plus the hydroxide concentration needs to equal 10 to the minus 14. So what does the hydrogen ion concentration have to be if we've got 10 to the minus 7 for hydroxide? There you go, because we want these exponents. So the hydrogen ion concentration would have a molarity of 1 times 10 to the minus 7. Hopefully at this point you can see 10 to the minus 7 and know right away that's going to be a pH of 7. POH, if we have the hydroxide ion concentration of 7, and it makes sense because the POH and the pH always have to equal 7. So I think we've answered the question here. Anything? May I go on, or do you have a question on that one? Number 3, hydroxide ion concentration, 1 times 10 to the minus 9 moles per liter. What is the pH of the solution? This is hydroxide, OH negative. So we want to find this one right here. So what exponent do we need to add to 10 to the minus 9 in order to get our 10 to the minus 14? 9, 10, 11, 12, 13. Yep. 10 to the minus 5 moles per liter would be our concentration of hydrogen ion. And 1 times 10 to the minus 5 becomes a pH of what? 5. Oh, and I guess you could have just done it this way too. Hydroxide, you could have figured that the POH was going to be 9, and we know that the pH plus the pOH has to add up to 14. You could have worked it that way too. You wouldn't have had to do all the fancy numbers. Number 4, hydrogen ion concentration. Okay, these are like now we're just kind of, okay, so this is the hydrogen ion concentration. Wait, hydrogen ion. Oh, be careful. I almost tricked myself. 1 times 10 to the minus 11. You should know right away that the pH is going to be what? 11. If you're not sure, you could put 1 to the exponent of 11, change the exponent, hit the log function, change the sign, and it's a pH of 11. Which means the pOH will be what? Because when you add those up, they need to equal 14, and we got the pOH of the solution right there. If they were going to ask what the hydroxide ion concentration, it would be 1 times 10 to the what? This is 11, that'd be 3 if they asked that. If the pH is 10, what is the concentration of hydroxide ion? Well, hopefully you can look at a pH of 10 and hydroxide. Okay, now be careful. See, I almost did the thing there. They're asking for hydroxide ion concentration. So if the pH is 10, what's the pOH going to be? 4. The pOH would equal 4. And if we've got 4 right there, what is that going to equal for a hydroxide ion concentration? This is kind of working backwards. 10 to the minus what? 10 to the minus 4. And a way you can do that on your calculator, pOH. So if the pOH is 4, you can enter in here on your calculator, you can do 4, but you got to change the sign because we're just reversing how you calculated pOH. So now we got to change the sign. And now instead of taking the log, you've got to take the anti-log, which is really 10 to the x. So in this calculator, second 10 to the x, and it gives us 1 times 10 to the minus 4, which is what we figured out, 10 to the minus 4. pH. Oh, let me make sure. Did we answer the right question? We were looking for the concentration of hydroxide ion. That's what we did. It'd be so easy to answer the wrong question. What is the pH if the hydrogen ion concentration is 2 times 10 to the minus 1, which translates into 0.2 molar? Does that make sense? You got that okay? That's 0.2 molar. I don't think we're going to ask you these on the test. We're going to keep them just straightforward. We're not going to put anything probably other than 1. But if you did, 0.2 molar. Okay, so that's the hydrogen ion concentration. That's the hydrogen ion concentration. 0.2. Going to hit the log function. Going to change the sign. The pH, is that what we were asking for? Yep. pH would equal 0. I'm going to round it to 0.7. Now, if this was just a 1, if this was just 1 times 10 to the minus 1, we know right away the pH is 1. But it's twice as concentrated. There's more acid. So it should be a little more acidic than a pH of 1. So it makes sense that this 0.7 is even more acidic than a pH of 1. Okay, this one right here. If the pH is 3.7, you just do the reverse of figuring the log. You start, here's what our answer was, 3.7. It's in the calculator. Now you got to change the sign, and then you're going to do the anti-log or the second function on log, and it brings us over here to 0.00019, or 1.9 times 10 to the minus 1, 2, 3, 4. But I don't think we've got these on the test. If we do anything, we're just going to say what's the pH, what's the concentration if the pH is 3. Pretty sure. And let's see, what is the pOH? I think these are getting repetitive now, so I think I'm going to stop right there. I won't talk through it. So pOH, if the hydrogen ion is this, okay, well if the hydrogen ion is this, what's the hydroxide ion going to have to, concentration going to have to be? Oh, is this going to be like 5 times 10 to the minus 6? Does that kind of work out? Because these add up and kick that over 1. I have to check on that one because I don't want to. I'll come back and get that one with you in a moment here. So I'm going to stop there because I don't want to tell you wrong because I got to wrap my head around that. But again, I don't think we're having those questions on the test. Oh, no, stop. Stop.